In 2013, a researcher at the University of Washington thought about pressing a button. He didn't move his hand, he just thought about it. But in another room across campus, a second researcher's finger involuntarily pressed a button to fire a missile in a video game. That actually happened. One person's thought was transmitted through a computer and used to control another person's body. And that experiment, which most people have never heard about, might be the first step towards something that sounds like science fiction, a brain-to-brain internet, where thoughts can be shared directly between minds. Let me explain what's real, what's possible, and what should genuinely concern us about this technology. Hey everyone, welcome back to Artificial Fluency Technology. Today we're diving into brain-to-brain interfaces, a technology that could either solve some of humanity's biggest communication problems or create the most invasive surveillance system imaginable. Possibly both. And I need to be upfront with you. Some of what I'm going to describe is speculative and very far in the future. But the foundation is real. The research is happening now, and the implications are worth thinking about before this technology gets too far ahead of the ethical frameworks we need to control it. Let me break down that 2013 experiment because it's wild when you understand the mechanics. Researcher number 1 wore a standard EEG cap. That's the thing with all the sensors that can read electrical signals from your brain. He was playing a simple video game where he could fire a missile. When he thought about pressing the fire button, the EEG detected the specific brain signal pattern associated with that intention. That signal was digitized and sent over the internet to a different building where researcher number 2 sat. He wore a transcranial magnetic stimulation device, a TMS cap, which can send magnetic pulses to specific parts of your brain. The TMS device received the signal and stimulated the part of the second researcher's motor cortex that controls hand movement. His finger involuntarily moved and pressed the fire button, even though he had no conscious intention to do so. One person's thought, transmitted through a computer, caused another person's body to act. That's a brain-to-brain interface in its most basic form. Now, before this sounds like telepathy or mind reading, let me be clear about what's actually possible with current technology. Brain-machine interfaces can detect and interpret very simple, specific thoughts. Things like move my hand, answer yes or answer no. They do this by identifying patterns in your brain's electrical signals, particularly in the motor cortex, the part that controls movement. These systems are already being used to help paralyzed people control robotic arms or type with their thoughts. Companies like Neuralink are working on implants that offer more precise signal detection than external EEG caps. But here's what they can't do: read complex, abstract thoughts. You can't hook someone up to one of these devices and download their memories, understand their conspiracy theories, or know what they really think about you. We're nowhere close to that level of detailed thought reading. The leap from detect the intention to move a hand to understand complex human thought is enormous. We might get there eventually, but we're talking decades, not years.
So why are researchers working on this? Because if brain-to-brain communication could be perfected, the potential benefits are genuinely transformative. Think about how inefficient human communication is. You have a thought in your head, maybe a complex idea or an emotion. You have to translate that thought into words, speak those words at maybe 150 words per minute, and hope the other person interprets those words the way you intended. So much gets lost in translation. A direct brain interface could theoretically transmit entire concepts instantly. No language barriers, no misunderstandings, just direct information transfer. The applications are compelling. A surgeon's decades of experience could be directly shared with a trainee, letting them feel the procedure through the expert's neural patterns. An experienced pilot on the ground could guide a passenger through an emergency landing by directly sharing the knowledge of how to fly. And the big vision, a network of billions of connected minds functioning as a collective intelligence, solving humanity's biggest problems like climate change or disease through coordinated global thought. That's the optimistic scenario. And I'll be honest, parts of it sound amazing. But now let me tell you why this same technology terrifies me, and why you should be concerned too. Your thoughts are the last truly private space you have. Even in the most surveillance-heavy society, your internal mental life is yours alone. A brain-to-brain interface threatens to eliminate that final refuge. If a device can read your thoughts, who else can access that data? Your government? Your employer? Advertisers? The same companies that already track every website you visit and every product you buy would suddenly have access to your actual thoughts. And it gets worse. Remember that 2013 experiment where one person's thought controlled another person's action? That wasn't just reading thoughts, it was writing to someone else's brain. The TMS device sent a signal that made the second researcher's hand move involuntarily. Now imagine that technology scaled up. External signals being sent into your brain to influence your decisions, your emotions, or your behavior. This isn't science fiction paranoia, it's a logical extension of technology that already exists. Before we talk about the security nightmare this creates, if you're finding this breakdown thought-provoking, don't forget to hit that like button. Comment with whether you'd want access to this technology or whether it scares you, and subscribe to the channel for more deep dives into technologies that raise serious ethical questions. The people working on this technology are starting to recognize the problem. There are proposals for neuro-rights laws, concepts like cognitive liberty and mental privacy, and discussions about neuro-cybersecurity, basically firewalls for your brain. But here's my concern. We've seen this movie before. When the internet was being developed, nobody built in security or privacy protections because the creators didn't foresee how it would be used for mass surveillance, manipulation, and addiction. We can't make that mistake again with something as fundamental as direct access to human thoughts. The stakes are too high. And there are other risks people aren't talking about enough. What happens when you can share consciousness with others? The document I'm working from suggests people might become addicted to that experience, preferring the intensity of shared consciousness to normal reality. That's not far-fetched. We've already seen how addictive digital connections can be, and those are just through screens. Direct neural connections could be exponentially more compelling. There's also the inequality problem. If this technology becomes available, there will be people who have access and people who don't. The connected ones will be able to share knowledge and experience instantly, advancing at an accelerated rate. The unconnected will fall further and further behind, creating a two-tier society based on neural access. Let me be clear about where we actually are with this technology versus where the hype suggests we might be going. What's real right now? Basic brain-machine interfaces that can detect simple intentional thoughts, like move left or select yes.
These exist and are being used medically. What's possible in the near future, 5 to 10 years, more sophisticated brain-machine interfaces that can interpret more complex commands and maybe transmit basic information between brains. Think simple concepts or images, not full conversations. What's speculative and far future, decades away, if ever, a brain internet with billions of connected minds, instant skill transfer, shared memories, and collective consciousness. This might be possible eventually, but we're talking about a level of technological advancement and neuroscience understanding we don't have yet. And here's something important. We might discover that human consciousness simply can't be fully digitized or transmitted. There may be fundamental aspects of thought and experience that don't translate to signals that can be sent through a computer.
So, what do I actually think about all this? I'm genuinely conflicted. The potential to help paralyzed people communicate, to overcome language barriers, to accelerate learning, these are real benefits worth pursuing. And the basic science of brain-machine interfaces is fascinating and could lead to medical breakthroughs we can't predict. But the risks of brain-to-brain interfaces specifically, not just brain-machine but brain-to-brain, are unprecedented. We're talking about technology that could enable thought surveillance, mental manipulation, and the erosion of individual identity in favor of collective consciousness. And my biggest concern is that we are not having these ethical conversations loudly enough or early enough. The technology will develop faster than the regulations, and once it exists, it will be incredibly hard to control who uses it and how. I also think there's a troubling assumption in a lot of this research that connecting minds is automatically good, that sharing consciousness will create empathy and solve conflicts. But what if it does the opposite? What if experiencing someone else's thoughts directly is overwhelming or disturbing? What if it breaks down the psychological boundaries that healthy people need? Look, I'm not saying we should stop researching brain-machine interfaces. The medical applications alone justify continued work. But the path from helping paralyzed people communicate to building a brain internet needs to be walked very carefully. We need robust laws protecting cognitive liberty before this technology becomes widespread. We need neural security standards before the first brain-to-brain social network launches. We need to have serious conversations about consent, privacy, and autonomy in a world where thoughts might not be private anymore. The 2013 experiment where one person's thought controlled another person's hand was an incredible scientific achievement, but it also opened a door we need to be very careful about walking through. Because once your thoughts can be read, shared, or influenced by external systems, the concept of individual autonomy changes forever. And I'm not convinced we're ready for that change. What do you think? Would you connect your brain to a network if it meant instant communication but potential loss of mental privacy? Where do you draw the line between helpful brain-machine interfaces and invasive brain-to-brain technology? Let me know in the comments below. If this exploration of brain-to-brain interfaces made you think differently about where technology is headed, consider subscribing for more discussions about the technologies that will shape our future and the ethical questions we need to answer before they arrive. Thanks for watching, and I'll see you in the next one.